Good afternoon all. It's 4 o'clock, or at least here at the continent, and welcome to the live webinar on the key changes in the new edition of the EN 15004-1. My name is Martin Franke. I will be your moderator for the upcoming hour. This is the last webinar that Euralarm will organize this year. The planned German version of this webinar is postponed till the next year, and we are more than happy to keep you informed on the new date via our LinkedIn channel. Some organizational matters. Your sound is muted, and so is your camera. Your camera is switched off. Any questions that you may have can ask either via the chat or via the Q&A channel on top of your Teams screen, or ask personally at the end of this webinar, where we plan some time to give answers to questions that you might have. For today, we have with us the chair of the Euralarm Extinguishing section, Alan Elder. But before I hand over to him, I would like to invite Peter Mita, as Euralarm president, to give a brief intro in the activities of our association. Peter, the floor is yours.
Okay, thank you, Martin. Can you please go to slide 1? Thank you very much. So welcome everyone to this important webinar on the key changes to the EN 15041. The slide just disappeared for a second. We appreciate your attendance and engagement as we discuss how these standards evolve to meet contemporary technological advancements. Standards are not static. They are living documents that undergo modifications to accommodate the latest developments in technology. This continual evolution is imperative for industries, particularly in fire safety and security, as it ensures that we remain relevant and effective in our practices. Through webinars like this, Euralarm provides a platform for professionals in the industry to stay informed about these changes and prepare for their implementation. Euralarm, as the leading European industry association, plays a crucial role in advocating for the fire safety and security industry. Our mission is to provide insights, advice, and expert knowledge to industry members, policymakers, and standardization bodies. The diverse nature of our industry has driven our division into 4 specialized sections, each addressing distinct areas. The first section concentrates on automatic fire extinguishing systems, highlighting various technologies, excluding sprinklers. The second section is dedicated to electronic fire alarm systems. This encompasses a broad range of components, including sensors, panels, and evacuation systems. Next, the service section focuses on the maintenance and reporting of alarm systems. Finally, we have our security section, which tackles intrusion protection, panic systems, access control, and video surveillance. Next slide, please, Martin. Thank you. On this slide, we highlight Euralarm's role as a leader in innovation for the fire and security industry, focusing on strategies that enable European companies to seize global market opportunities. First, supporting a single market is crucial for ensuring consistent high standards across borders. This unified approach not only enhances productivity, but also accelerates innovation. In addressing the challenges of digitalization, Euralarm is committed to equipping the sector with the necessary tools and frameworks to adapt to emerging technologies. This alignment is critical for harnessing the full potential of innovation while upholding safety standards. We also stress the importance of a sustainable supply of innovation, promoting ongoing research and development with a focus on environmental consciousness. This commitment prepares the industry for future challenges and positions it as a leader in sustainability efforts. Moreover, a qualified and well-trained workforce is vital for effective design, installation, and maintenance of our systems. Investing in education while attracting young talents to our industry ensures we remain competitive amid the demographic challenges that are shaping the European population. Contributing to a green Europe presents an opportunity for growth, aligning our practices with climate objectives and reducing our environmental impacts. Additionally, embracing a diverse workforce fosters creativity, enhancing industry performance and adaptability in a changing competitive landscape. Before I close, I once again wish to express my gratitude for your attendance today. And for those who are not yet members and wish to join our efforts, please feel free to reach out to me directly or visit our website for more information. With that, I hand over the floor to Alan. Thank you very much. Alan, the floor is yours.
Okay, thank you, Peter, for the introduction there, and welcome to all our guests who've joined the webinar this afternoon. The presentation we've put together will take around about 30-35 minutes. The topic, as you will have seen, are the key changes in the new edition of EN 15004 Part 1. I think that the importance here of the changes in the new edition allows us to dedicate the whole of the session to those changes. It's not the intent to do a deep dive on the standard itself. This, as you will see during the course of the presentation, is the third edition of the standard. And I would imagine that the majority of practitioners in this field are already familiar with the general rules that apply to the design of systems in accordance with 15004 Part 1. Could you advance the slide, Martin, please? So the topics I will cover today include a brief background and anticipated implementation of the revised standard, and the key areas that are at variance or different to what is in the currently published version are those listed on the rest of that slide. We'll talk about the effects of noise, the new requirement for actuator placement indicators, references to an already published existing EN ISO standard on enclosure venting, a new section on hazard classification, new agents. How do we actually include new agents into the 15004 standard? A new section on toxicity thresholds, and finally finishing off with scaling factors which apply to Class B materials. So if you move on, please, Martin. So changes in the background. So I think without doubt, EN 15004 Part 1 is the most widely used clean agent standard in Europe. The basis of the standard is ISO 14520 Part 1. It's effectively identical with 15004 Part 1. So when we talk about 15004, we can assume that in general this standard has more than just a European appeal. It has a global appeal on the basis of the ISO 14520 series as well. The latest revision to 14520 was published in 2023, and as has happened throughout the history of 15004, as the ISO standard is published, we take a look at the changes in the ISO standard, we debate those amongst the technical experts in TC 191 Working Group 6, and we go through a process of implementing the parts of 14520 that we believe will enhance 15004. We go through a process where there is public input and inquiries take place, and then we go to the final stage, which is a formal vote. This is a vote on the implementation of the standard in its final form. I am pleased to report that the standard 15004 Part 1 has passed its formal vote and is approved for publication. I may say this more than once during the presentation because I'm really excited about this, but we are anticipating that the standard will be published next week. We have a date in the SENS system of the 11th of December 2024, and so I feel confident that we will see this standard on the street by the end of this year. I think, most people are familiar that apart from the EN and the ISO standards, there is also NFPA 2001. And for those people who work outside of Europe, perhaps in the Middle East and parts of Asia Pacific, and certainly the United States, will be familiar with NFPA 2001. I think the key difference, if when people ask me for the key differences between 2001 and 15004, I say the one key difference is that there are higher design concentrations in the European and the ISO standard compared to NFPA 2001. That there are a number of reasons for that, and that's not really the subject of today's webinar, but we'd be happy to talk through those differences on another occasion. So if you move on, please, Martin. So let's have a look at the implementation. So the first edition of 15004 was published in 2008. It was revised 5 years ago and is now imminent in 2024. With this being a European standard, what this means is that when this standard is published, it must be adopted by all SEN members. Any conflicting standards or any standards that are in current use, including the 2019 version, must be withdrawn in favour of the latest edition. It's published as national standards in all SEN member states. So just as a couple of examples, in Germany it will appear as DIN EN 15004 Part 1, in the UK as BSEN, Spain, UNI, etc. And those are the SEN member states. So this does stretch beyond the EU, and I'm speaking from the UK, so I know all about that. But it does stretch beyond the EU, and you will see some other countries there that are all members of the SEN community and adopt this standard as written. We move on, Martin, please. Okay, so we move on to the first subject, and this is a new topic that's been introduced into this edition of the standard. For the first time, the standard includes requirements to consider the effects of noise in sensitive areas. And for sensitive areas, we're mainly talking about data centres, and those data centres containing certain hard disk drives. We're aware of as an industry of incidents being reported as far back as 2007, and then seeing complaints of hard disk drive damage and some data loss. Contrary to some belief that this only applies to inert gases, it also applies to the halocarbons as well. It is all about the noise that is generated during the discharge of a system. It is not only the gas and the noise of the discharge of the gas, it can also be the alarm devices that are within the protected space. And what the new edition of the standard does, and I've repeated the whole of the clause there, it says that the effects of noise can be the alarm devices, which are used to warn personnel to leave the area before an agent discharge, and the discharge of the agent itself. Typically, the output from the alarm devices is available from the OEMs of those alarm devices. But noise from the discharge of the system can be very significantly, according to the type of system used, the discharge time of the system, the proximity of the discharge devices to equipment such as the hard drives, and also whether that equipment itself has any form of noise damping. And so what the standard does is in that last sentence. It says this could include installing the sensitive equipment in soundproof enclosures, changing the nozzle spacings, and or using nozzles and alarms that have been developed to reduce the sound output. I think the most common method here of mitigating against this noise in respect to the discharge is to include acoustic nozzles, and there's a number of those on the market from the various OEMs, and there's some pictures of some of the ones that you may have seen in practice. So different configurations, different technologies there, but all designed to reduce the sound power from the discharge nozzle itself. Okay, Martin. So the next one is a requirement in the standard to include actuator placement indicators. Now, for those who've been in the business for many, many years, will fully appreciate that the electrical cabling that goes to the actuators used to release the system are monitored in case there's a break in the wiring. So in other words, if the wiring gets cut, there will be a signal given to the control panel to say that there is a fault indication here. And you can go to the actuator device and you can see that there may be damage to the wiring. Now, during the maintenance activities of systems, which normally takes place at least every 6 months, the actuators are removed for testing. That does not necessarily include disconnecting the electrical wiring. And there have been anecdotal reports that during maintenance activities where the actuators have been removed, they have not been replaced following the maintenance work. That would render the system ineffective and incapable of discharge. So what has been introduced in this version of the standard is a requirement to provide a signal if the actuator is required mechanically from the container valve or from the selector valves it controls. So what we've now got is that we've got the requirement to provide a signal in the case of a break in the wiring, a break in electrical continuity, or if the actuator itself is removed from the cylinder valve. Now, this has been an NFPA requirement since 2016. It was actually introduced into the 2012 edition of NFPA and was mandatory since 2016. So you can see the clause there, the wording in the clause, quite straightforward. Removal of an electrical actuator from the agent storage container valve or selector valve that it controls shall result in an audible and visual alarm of system impairment at the control panel. It's a mandatory requirement. You'll see there that it says shall, and that means it must be implemented. Martin, please. So the next one is a topic very familiar to the industry, and this is the one of enclosure venting. It's well known that when you discharge a volume of gas into a protected enclosure, depending on the gas tightness of the enclosure, you will experience varying levels of pressure within the space. The inert gases exhibit a positive pressure excursion, and with the halocarbons, you will get both positive and a negative pressure change within the space. In 2023, a new ISO standard was published, which is ISO 21805. It was published as a joint work item with CEN and is published as EN ISO 21805. For the first time in the EN 15004 standard, a requirement to take notice of EN ISO 21805 is there, and you will see again the clause: the protected enclosure shall have sufficient structural strength and integrity to contain the extinguishing discharge. Venting shall be provided to prevent excessive over or under pressurization of the enclosure. Guidance on gas system venting can be found in ISO 21805. So again, giving strength to the arguments to include the appropriate levels of pressure venting within a protected environment. Okay, Martin. This is one that is a little bit more complicated to explain. Within the ISO standard and subsequently in the EN standard, Class A hazards have been designated as either a regular Class A hazard or a high hazard Class A. This is a little different to what's contained within NFPA 2001, which talks of a regular Class A and then talks about a Class C hazard. And whilst the comparison between high hazard Class A and the US Class C are not identical, it is a similar definition of what would be included. And what we've found is that there has been some confusion in which circumstances to use the regular Class A or the high hazard Class A. And so the revision to the standard provides examples of when to use each classification. In bold there, I said it is largely dependent on interconnections and airflow between the protected spaces. And it's clear that in any one protected enclosure, there are different scenarios that could exist, which need to be considered when selecting either the regular hazard or the high hazard Class A concentration. And I think the key here is where you've got communication between the high hazard area and the regular hazard area that is driven by some form of forced ventilation, then you may well need to consider the high hazard classification throughout. Go on, Martin, please. And so in this slide, we've identified 3 fairly common scenarios that would exist. So scenario 1, this is where hazards with both a high hazard, say floor voids with cables, and regular hazards, for example, the room, with no recirculating air present. What you would do in that situation is you would use the high hazard concentration in the subfloor and a regular Class A concentration in the room. In scenario 2, where you have a high hazard classification, for example, the floor, and regular elements in the room, with no shutdown of the recirculating air, you would use a high hazard concentration throughout. If you don't do that, what would happen is that the airflows between the spaces would start to dilute the concentration within the subfloor and in some way increase the concentration within the room. So the guidance is to reuse the high hazard concentration throughout both of those spaces. And the third scenario is where we have hazards with no obvious high hazard elements, including the subfloor, or where the subfloor does not meet the criteria for being classified as a high hazard. And in that case, you can use the high hazard concentration throughout, unless it cannot be determined to be a regular hazard only. And just to give an indication of what the differences are, you can see that if you take the inert gases there, and just taking IG55 as an example, the concentration for a high hazard versus a regular hazard is around about 10% more. So you're going to use 10% more agent, you're going to use 10% more containers, you're going to potentially increase the size of the pipework and the installation. And with the halocarbons, there is also a difference. The regular hazard for FK5112 is a 5.3% concentration, and a little bit more for a high hazard concentration at 5.6. I think I would always say and always urge people that if in doubt, use the high hazard concentration, but providing you can categorize the hazards adequately and properly, you can make a choice there to split it in a particular installation. Okay, Martin. So the next topic is the clauses. It's actually contained in a new annex. It's Annex J of the standard. This is a normative annex, which basically means it must be followed. And so when a manufacturer of a new agent offers that agent up for inclusion in the standard, in the past, I'm not saying it was totally ad hoc, but I would say that there were certain criteria that the manufacturer needed to supply, but it wasn't nailed down as much as it perhaps should have been. And so in the version of the standard, in the revised version, there are some very important and critical data that must be provided by the manufacturer. And most of this must actually be independently assessed by test laboratories and third-party accredited. So the first thing is an identification of the material itself. What is the chemical formula? What is the specification for the agent? You know, what are the toxicity and the impurity profiles that are permitted for that agent to perform in the way it's designed to do? What are the physical properties? What are the extinguishing and the design concentrations for that agent, which must be verified by independent test laboratories? Toxicity information, the system design criteria, and importantly now in many European standards and across the world, what the environmental properties are of that agent. So we talk about the safety aspects of the agent, but also about the global warming potential, atmospheric lifetime, etc. So that now is mandatory according to Annex J of the standard, that if a new agent is offered into the technical committee, that the manufacturer, before it would get to the stage of being published, would need to provide all of that information, and for that to be peer reviewed within the technical committee as meeting the requirements. Next one, Martin, please. So people may be aware that following this new procedure, a new agent was introduced into the standard. And for those not familiar with the way that the series works, EN 15004 Part 1 contains specific requirements that are applicable to all system technologies, and then individual agent parts address the specific properties of individual agents. The agent that was more recently introduced is known as HB55. The HB stands for halocarbon blend, and 55 describes that it's a 50-50 mix of two other components. And those two components in this case are HFO 1233ZD and FK5112. And they're introduced in equal measures of 50% of each of those. This was a proposal that originally went into the ISO standard by the US. Fire data was produced given a design concentration of 7.8% and with safety data of 8.7 being an NOAL. It's got a boiling point of 20.7 degrees C, GWP of 1, 0 ozone depletion potential, and it is, like other halocarbon agents, it is within the F-gas regulation proposals, but is not restricted. Now, just as an update, and I won't spend more time than necessary on this particular agent, the manufacturer of this agent has, at this moment in time, decided not to further commercialise the agent. But I didn't want to omit a change to the EN 15004 Part 1 if you suddenly see EN 15004 Part 11 referenced. You know, that is published. It is mentioned within Part 1, but the manufacturer at this time is not proceeding with commercialisation or full commercialisation. They have actually obviously gone to the stage where they've got all of this important data, but in terms of promoting and further commercialisation, they've put that on hold at this stage. Okay, Martin. The next subject is in respect to toxicity thresholds. So most people who would be familiar with the individual agent parts would be aware that the general purity level for the agents is 99%. It does vary, it can be 99.5, it's 99, but generally it's of that order, which permits around about a 1% impurity level for that agent still to perform and do its duty as a fire extinguishing agent. It does already specify within the standard what the maximum levels of acidity are, water and non-volatile residues. What it does not do is take account of what is permitted to be in the 1% of the impurities. And as a result of that, new thresholds have been added for FK5112 agent and by definition of HB55 because it is 50% composing of FK5112 for HFP dimers. So there's two dimers that have been referenced. The dimers are kinetic dimer, which is has to be present at no more than 2,850 milligrams per kilogram, and thermodynamic dimers at less than 95 in respect to FK5112. So those are new requirements that the manufacturers of FK5112, and we do know that since the 3M decision to cease production of Novec 1230, that a number of manufacturers are offering for sale in the European market FK5112, and it will be incumbent on those manufacturers to comply with these thresholds for these two dimers. Okay, Martin, please. The next subject is respecting scaling factors. Now, scaling factors in this context actually only apply to a fairly small part of the market, because what they do is apply to Class B hazards. So if we look at Class A fuels, which are typically those containing electrical equipment, data centers, electrical switch rooms, etc., in order to determine the extinguishing and therefore the design concentrations, we have to do a full room test. So there are a number of tests that are identified within the standard, including wood crib and 3 plastics with repeatability, with certain pass-fail criteria. In respect to Class B materials, which are flammable liquids, the requirement in the standard is to carry out a cup burner test, which is a small-scale laboratory examination of the extinguishing concentration of the material. Only heptane has a full room test. So where we have with Class A fuels a full room test, we're only required to do that for heptane. So with the heptane as the fuel, we take the higher value of the cup burner value and the full room test, and that is used as the design basis for the design concentration. And so the question is asked, well, what to do for other Class B fuels? Because other Class B fuels may behave differently in those two experimental examinations than heptane does. And we do know of some examples where a cup burner value is given for a Class B material, but the full room may actually result in a higher value. Now, as written in the previous edition of the standard, it was only necessary to take a cup burner value. So let's say you had acetone as a fuel, and you carry out a cup burner examination, and you get a certain value for your extinguishing agent for acetone. That would be used as the basis of the design concentration. What the standard now recommends, and I'm saying recommends because this is actually an informative annex, so it's not a normative annex in the standard. It does say that what you should do is carry out a cup burner and a full room test for 3 fuels. And those 3 fuels would be heptane, acetone, and methyl alcohol. And what you do is that you take the highest of the values of those and you apply a scaling factor. So if the full room test for the worst case of those three fuels required a 40% safety factor or scaling factor, you would apply that then to those materials. In the event that a scaling factor is not available for the Class B fuel, in other words, when no full room test has been carried out, the standard suggested or suggest a preliminary scaling factor of 1.15. So if you only have a cut burner value for a particular material, then the standard recommends that you apply a 15% uplift to that cut burner value. That would not apply to heptane because heptane already has a cut burner and a full room test concentration specified. But if you have another Class B fuel where the full room test has not been carried out, then the standard would actually suggest a preliminary scaling factor of 1.15. There was an ISO technical specification 12845 that suggested this initially. The reason I say it was suggested, that preliminary scaling factor of 1.15 did not carry through into ISO 14520, but does carry through into EN 15004 Part 1. And so you can find that detail in the informative Annex I of the standard. Okay, Martin? Okay, so those were the main changes to the standard. There's always other changes, you know, whether it's minor editorial, whether there are updates to the forward, because we're identifying within the forward changes from the previous edition. And all of the changes that I've described in today's session are included within the European forward as the introduction to the new version of the standard. So the Euralarm extinguishing section has followed the changes to EN 15004. Many of our members actually sit on the Working Group 6, which has been instrumental in developing the changes to the particular standard. And we welcome the improvements that are contained within this standard. People often ask whether changes to standards are retrospective. And unless there is a real issue with what was contained within a previous edition of the standard, the answer is no, they don't apply retrospectively. There is nothing within the changes to the standard that should give people concerns over what has been done previously according to the 2019 edition. But what we should do is that we should go with state of the art, and immediately the 2024 edition is published, we should be implementing these new requirements into the design of systems as we move forwards. So I think that covers the main aspects. You may move on to the final slide, I think it is, Martin, which is the questions and answers session. Over to you, Martin.
Thank you, Alan. Questions is something that the audience has to come up with. I think that I can only ask you for the answers. So, audience, do you have any questions? Or did Alan push all the right buttons? Or was the presentation so informative that everything that needed to be answered is already answered? That's also a possibility, of course. Any questions? Just raise your hands, and if not,
just while we're waiting for any questions, Martin, we should just also point out that Euralarm has produced a guidance document on this subject, and I think we are just dotting the I's, crossing the T's on the revised version of that, and I think that will be appearing on the Euralarm website imminently. You would know better than me, Martin, exactly when, but I think within the next day or two, we will see that. Yeah,
that was on my list as a final remark, Alan. the latest version of the document, the guidance document that covers this topic, is on our website currently for download. Just for your information, or for colleagues that might have missed this event, the presentation that Alan just did will be online as of Thursday. So if you want to share it with your colleagues, that's also possible later this week. I see one question coming up, Alan. You must be able to read that as well in the chat. Hello, from 2000 were with the hard disk drive, but currently we have SSD. They are not sensible to noise. Yeah, that sounds.
Okay, so there is a question about the reported incidents from 2007 where with hard disk drives, but currently we have solid state drives. So obviously, in respect to solid state drives, that those noise concerns would not exist. We hear for a long time about the data center industry moving to solid state drives. We are aware through our membership that there are still a significant number of regular hard disk drives out there that would be and could well be sensitive to noise. So I think that solid state drives will ultimately take away that as a concern, but at this stage we're not there yet. There's still a lot of hard disk drives out there that could be sensitive to noise. Then there is another question about, will the cold aisles in data center rooms be revised in the next version of the standard? I think that what we've tried to do, and Euralarm and other trade bodies that we've been interacting with, have produced guidance on the effects of high air flows and movements within the cold aisles and hot aisles within data centers. And in fact, just in the end of October, Euralarm produced a guidance document on the impacts of high air flows within hot and cold aisles within data centers, and that is a really informative read. It actually followed a fairly extensive research project that was carried out by the FSSA from the United States and the FIA from the UK, and the document goes into the findings from that research project and tries to simplify them down to a few pages as opposed to the full report, which is also available if necessary.
One last one. I think, Alan, as the new standard is not retrospective, would it best be best practice to implement at the 10-year overhaul?
And I think the answer to that question is that if when you see the detail of the new standard and you see any of the changes that we've discussed today as not being implemented in a system that was installed prior to the standard. So, for example, the hard disk drives, is there a risk to the hard disk drives because acoustic nozzles have not been fitted and them being sensitive to noise? So it would certainly always be worth looking at that. I think some of the other things, such as the concentrations, the design concentrations, I did mention that the concentrations within the European standard are quite a bit higher than NFPA. And I think as an industry globally, we don't have adverse reports of systems failing to extinguish fires in real life discharges. And so we have safety factors there. They are there for a purpose. But if somebody does wish to upgrade the level of protection from a regular hazard to a high hazard, now that the that clarification has been given and what constitutes that, then of course that would be something to discuss with the system owner. Placement indicator switches, obviously an important enhancement in the 2024 edition. It just gives an extra level of assurance if that is introduced as a retrospective measure. But as a general rule, the standards are not retrospectively applied. But good practice may dictate that certain aspects do get integrated into existing systems.
I think that is the last one.
Yes, yeah, and there is actually a question about specific levels of noise,
Yeah.
and the answer to that very clearly is yes. The sensitivity to noise is very much dependent on the frequency, and so there have been a number of white papers that have been written by some of the OEMs. Siemens have written a white paper, JCI, Johnson Controls, have written a white paper on that, and there may be others that have done so. So if you search out those papers, there is certainly commentary on the impacts and the importance of the frequency as it affects to the noise that could impact on hard drives.
Okay. I think that's it for the questions and answers. Having said that, I would like to thank Peter and Ellen both for their presentation. I would like to thank you, audience, for being here. As I mentioned, the webinar will be online soon on our website. You can also find the document that Ellen mentioned. For now, I would like to wish you a nice evening. Have a nice evening, and we hope to welcome you during one of the next events that we will organize. To know what event it will be, just follow us on LinkedIn and make sure that you get the updates of the latest news and developments in our industry. For that, so far, thank you very much, and hope to see you soon.
Thank you.
Thank you.